before he joins us. To give you a little background on Helicoid Industries, this company has patented technology exclusively licensed and ready for commercialization in our industry. Their structure is a platform technology that can easily be applied to numerous industries that are constantly searching for lighter and stronger components. I'm intrigued about this. Their technology is based off of a sea creature, the mantis shrimp. And you'll hear Lorenzo talk about that, how they got the design. I was like fascinated by this, learning more about the shrimp and just the capabilities of it under, attacking its prey, and how it uses this little club to crack the shell of crabs, and just how this material is based off of the design of that. It's fascinating. But Lorenzo, thanks for coming on and spending some time with me today. Their technology they were up for a finalist for the ACE and the CAMX awards, and they were at CAMX a couple of weeks ago. Lorenzo, thank you so much. I'm sorry that we didn't get a chance to see each other at CAMX, but maybe next time, right, in person.
For sure. Thank you very much, Jonathan, for having me here today.
Yeah, absolutely. Well, tell us a little bit about, before we get into Helicoid architecture, your company, how you, let's talk about your background in the industry.
Sure. So I'm an aerospace engineer by training, and I've actually spent quite a few years in doing academic research before joining the industry landscape. I've got a PhD on designing microstructural features for advanced composite materials to improve specifically damage tolerance and other dynamic type of loading, such as impact. And actually, part of my PhD research was focusing on the mantis shrimp architecture and how we could translate that into advanced composite materials. And that's how I got in touch with Helicoid Industries, actually, and that brings me here today.
So it's fascinating. Let's get into the background of where this originated from, the mantis shrimp. Talk about that, the design of this creature's, I guess you would call it its club that it uses to attack its prey. There's something really unique about that. The fact that it's the amount of impact that it delivers with one or two swings is amazing. I mean, it's like the energy that it delivers on a full swing is pretty extraordinary.
Yes. So it's a pretty interesting creature indeed. And as you correctly described, it uses these clubs that are deployed underwater at very high speeds. They create cavitation. So it's a highly stressed structure that is able to crack and smash shells, which are considered to be quite tough themselves. So this club not only has to resist a single strike impact, but it has to resist multiple impact across, the lifespan of the of the shrimp. So it's pretty interesting when you look inside the club in an SEM machine and you try to get some imaging to understand what's going on inside the microstructure. You will see that this is in fact a fiber-reinforced composite architecture, fairly similar to what we used in industry today, made out of several unidirectional layers, which are slightly rotated one with respect to each other to form this helicoidal distribution of fibers. This is also combined in the actual club with a top ceramic layer. It's a very multi-material, articulated type of structure that delivers this high impact performance. But what we did at Helicoid was to leverage years of research, especially done by University of California, Irvine, where the first patent on the technology was actually created and licensed exclusively to Helicoid Industries. And since then, we have developed our own IP portfolio of patents to be able to translate what is a lab discovery to an actual component, make it viable, make it scalable, and make it applicable to multiple products in different applications.
That's fascinating. So, I mean, with going back 14 years, what is it? 14 years of research on this particular technology, $12 million. I mean, of research. I mean, it's amazing. I was just looking earlier when we were talking, just the speed of this club is it's stronger than a 22 caliber bullet. I mean, that's pretty amazing. So tell us, I mean, talk about maybe some industries that you have partnered with and companies that you partner with. As you can see, our listeners can see on the website, you guys have been gaining some major recognition for your innovation. You guys are featured in Forbes magazine, Bloomberg, as well as others. If you would share some industries that you're working with and applications. Obviously, we talk about the energy sector, the wind energy, obviously aerospace. I'm sure that you guys are heavily involved there, but maybe let's talk about some of the industries these applications are taking shape in right now.
Sure. So it's the reason why we are able to target so many industries and different applications is the fact that the technology is really raw material agnostic, right? It's a fiber architecture that can be used with virtually any type of fibers, any type of resin. Of course, we have our own trade secret and recipe to we are able to design the optimized architecture for that specific combination of resin, matrix, and overall part requirements. But basically, at the moment, our entry market is being sporting goods. We have just launched a couple of months ago with CCM hockey, where we are deploying our technology on the blade of the hockey stick to improve durability and response. And we are also launching in a pickleball racket, hopefully anytime soon, deploying the technology on the skins of the pickleball using natural fibers in combination with thermoplastic solution, while the hockey stick is a carbon fiber thermoset solution. So this gives you an idea also of the flexibility of using the technology with different type of materials. We have several applications on helmet, from motorcycles to horse riding helmets to bicycle helmets that are in the pipeline. In automotive, we have building a very good relationship with TPI Composites and to deploy the technology into their underbody protection panel for EV cars. So it's basically it's the only physical barrier that separates the battery pack of an EV car from the road. So it has a very important impact resistance requirement and also deflection requirement to protect the battery pack. And we have been demonstrating the value of the technology in that application, resulting in being a lower cost, lower mass, and a much better impact performance than an aluminum design. So we're ticking all the boxes there.
Yeah.
And that's our primary application at the moment in automotive, but we're also looking at bumper structures. We're looking at damage tolerance and safer seats. Moving towards wind energy, this is pretty interesting because basically we approach the problem of rain erosion in a very different way as the industries used to do. So we have been looking at the rain erosion as an high frequency, low energy, high speed type of impact of rain droplets on a surface, on a component. So if you look at that event, at those high speeds that the tip of the blade reaches, especially for offshore applications, you've got a stress wave traveling in your structure. And the way the stress wave that causes damage in the structure and the substrate, it's heavily driven by the layup architecture as well. So we have been playing with our helicoid fiber architecture to see if we could bring benefits in terms of better resisting rain erosion of the leading edge of wind rotor blades. And we found out to be able to delay by very around 34% the erosion of the mass that is eroded under the operative condition of the blade. So that's solving a massive problem of these blades, because the erosion not only causes a loss of aerodynamic efficiency of the blade, so you are producing less energy, but if it gets too deep into the blade, then you need to stop the blade and make maintenance. And you are talking about doing maintenance offshore on a massive structure, so it costs
a lot of money there, right? I mean, that's a lot of
right. So we are able to deploy this in again using standard fiber used by the wind industries, using the same resin in the same manufacturing process. It's a very plug and play solution once it's been designed, that solves a big issue. And this could be applied also to other aerospace related applications where you have a high speed rotating component that might suffer from erosion, either from sands or particles or rain itself. We've been in aerospace, we've been looking a lot on components like containment casing of jet engine. Basically a ring of composite materials around the fan of the engine that has the only function to stop a blade in case of a blade off event. So you imagine an engine rotating at full speed. You have a burst strike, something, a blade breaks and it shoots outward. You don't want that blade to go into the fuselage or the wing. You want it to be contained, right? And it's a high mass, high energy type of impact. And therefore, our solution has demonstrated to be excellent for this type of applications. We have an ongoing large R&D projects with a multi-company consortium where we are looking at using the technology also in the airframe of the structure. This becomes particularly interesting when you move towards eVTOL or smaller scale aircraft where you have more complex geometries, you have a much more multi-directional type of load in the structure. So a conventional way of designing a structure that uses fibers only in the 0, plus, minus 45, 90 degrees orientation, it's no more efficient, and it doesn't allow you to hit that weight saving targets that you're looking at to achieve the benefit in this type of a smaller scale aircraft. We're working also in defense. We have a contract with the Department of Defense where we are deploying the technology in some ground interfaces used by the Army. And let me think what else.
I would think ballistic applications would be a definite interest there.
Yeah, ballistic application as well. We're looking about that, especially for armor applications and applications where you want to limit the back face deflection, so to prevent from trauma. For instance, our solution is really good at limiting that specific deflection. So defense is certainly another space. We are also exploring because it's so flexible, the technologies, that you have so many things that you could be looking at the same time. So two areas that where we are stepping in at the moment that are super interesting are healable composites, and the reason is we didn't go into the detail of why the technology performs so well, but one of the mechanisms is basically the ability of dissipating an incoming energy of an impact, for instance, via promoting matrix damage instead of a fiber failure, right? A composite can only fail in certain way. Either you have fiber failure, matrix damage, or delaminations. If you break the fibers, you lose structural integrity. So you would tend to favor matrix failure and lamination instead of fiber failure. So
Sure.
our technology is able to kind of steer the damage towards a more favorable way of dissipating energy. And this allows us to heal the composite and recover completely the performance, right? Because if you imagine to use a thermoplastic resin or a Vitrimer resin or any resin that is reprocessable, once you have damage, because it only had matrix damage, you are able to recover that.
Okay.
And you recover completely the performance of your structure. So that's a very interesting area.
Yeah.
And
it all is down to, I mean, it comes down to, as we talked about in the beginning, the way the fibers are structured, right?
Yes.
I mean, that's the bottom line. It has nothing else. I mean, yeah. So it's,
and the beauty of it is you don't have to rely on complex woven type of structure. Like it's not like a 3D woven or 4D woven, which is pretty expensive, pretty complex to produce. It's really a basically optimized layup sequence. So you can use it with the multi-action non-cream fabric technology. You can use it with the automated tape layering, automated fiber placement, filament winding, and layup. So it's pretty flexible, and you don't require also any capital investment, right, to deploy it. Because if you are already able to process continuous fiber composites, then you're able to process helicoid composites.
So how are you, as you guys, first of all, you guys are based over in England, correct?
No, so the company is based in California.
California, okay, I'm sorry. You're based in England.
I'm based in England, and we have a subsidiary here in England.
Oh, okay, I understand. That's so are you partnering? I know you mentioned some of the collaboration with TPI Composites. Maybe you could talk about that. So you're developing, obviously, the fiber lay technology. When you talk about like companies that are doing filament winding and things like that, how do you collaborate with companies with filament winders or people that are using different applications to apply?
Yeah, so in that, I believe we have a very versatile value chain integration. And the reason is we effectively work as a engineering and design company, right? We license the technology. That's our revenue. That's how we make money. And this allows us to work, for instance, with a tier one supplier, TPI in this case, for the underbody protection panel, and to work with their design team. We get their component, we do analysis in-house, we do a lot of FEA modeling with damage modeling as well, where we redesign the part to meet certain performance target, whether it is structural performance or reducing weight, reducing cost. And then we pass that design on to our partner again, that does all the evaluation that it is required for that component, and then we move towards the licensing. So if that could be one option. Another option is with the if the solution could be integrated, as I mentioned, on the multi-action non-cream fabric, where you embed the different fiber orientation in a single fabric solution. So in that case, we would work with a weaver of a multi-action non-cream fabric to use the technology, to deploy the technology into their fabrics, and then they would be able to sell fabrics that embed helicoid technology. So that's how we that's why partnerships for us are vital, because is the way we deploy the technology into the market.
Absolutely.
Through these vehicles, basically.
Fascinating. Yeah, I was reading some of the, you mentioned, we were talking earlier, you had mentioned the partnership with TPI or working with TPI. And I noticed that some of the, the EV space, and you may have touched on this, I just didn't catch it, but the, the battery casings, those are big industries as well, that are fantastic applications for this. And we can see it more and more as we move towards that EV market, or that EV market continues to increase, those are definitely industries that you guys are involved in.
Absolutely, yes. Yeah. Not just on the commercial automotive, but we are looking at, because eventually the enclosure is a protective case, right? For a key
Absolutely,
component of your product. So we are looking at also the same type of applications for heavy duty trucks, or for aerospace related application, from some defense related application. So again, you can really use it to achieve both very lightweight solutions, but at the same time solutions that are really tough and strong.
You mentioned what part of California are you guys located?
Is Indio.
Okay, is that where your R&D, I guess your research facility is?
So we have a lot of research facilities, if you want, meaning that we have a very strong network of partners through which we do research activities. We collaborate with top tier universities around the world. We have partnerships with Purdue University, University of California, Irvine, Michigan State University, Imperial College London in the UK. So we are really spread out in terms of accessing high-end research facilities to demonstrate the benefit of the technology.
That's fantastic. You guys do any work with Clemson, the Clemson composite team over there?
No.
We don't. Okay.
We keep that in mind.
Well, this has been fantastic, Lorenzo. I want to mention where our listeners can find out more, and I've had your website in front of us, and that is helicoidind.com. That's correct?
That's correct. That's a source. You can follow our LinkedIn page. You can find myself on LinkedIn, and most of the you will find on the website an email, and rest assured that most of the emails will be redirected to me. So I'll if you get in touch, you will get my reply soon.
And just so they know, I want to mention some of the engineering services that are provided include the laminate design and material selection, prototyping and lab testing, product manufacturing and process and integration. And then obviously you guys, you have access to research with some of the facilities that you've mentioned for the testing and manufacturing of these materials. It's fascinating. I could spend more time talking about this today. Unfortunately, we're short, but I'd love to have you back on and certainly follow back up with you. I know you'll be, as I mentioned earlier, you guys were up for ACE Award and CAMEX Award. So congratulations on that. And hopefully we get a chance to meet in person at either JEC or at CAMEX this upcoming year.
Yeah, it will be GEC for sure.
Yeah, for sure. All right, Lorenzo, thanks so much for coming on. And again, that is Lorenzo Mencattelli. He is the Managing Director of Technology and Operations at our friends at Helicoid Industries. I want to say Helicoid Industries. And if you haven't had a chance to check out some of their stuff, we're going to be posting some of their the YouTube videos that they had that just shows kind of the origin of this technology, and I think you'll find it interesting. But Lorenzo, thanks again for spending some time with me today, and hope you have a great weekend upcoming.
Thank you, Jonathan. You too.